In this video, we'll draw the Lewis structure for Al2O3. This is aluminum oxide. So the first thing we really need to understand is that aluminum, that's a metal. Oxygen, that's a nonmetal. So typically when we have a metal and a nonmetal, we have an ionic compound. If we look at the difference in electronegativity between aluminum and oxygen, we'll see it's 2 or greater. So this is definitely an ionic compound. With ionic compounds, we're going to transfer electrons. For covalent compounds, something like CH4, where we have 2 nonmetals, we'll share them. But with ionic, we're going to transfer. So we have to write this a little bit differently. Let's do that. So I have 2 aluminum atoms. I'm just going to write 2 of these aluminum atoms here. And then we have 3 oxygen atoms. So we'll just write them over here. So on the periodic table, aluminum, that's in group 13, sometimes called 3A. It has 3 valence electrons. I'm just going to put 3 valence electrons around each aluminum atom. Oxygen's in group 16, sometimes called 6A. It has 6 valence electrons. So we'll put 6 valence electrons around each oxygen atom. So we said we have an ionic compound here. The electrons are going to be transferred. So each aluminum will transfer its electrons, because it's a metal, it's less electronegative, to the oxygens. So let's just distribute all of these electrons from the aluminums to the oxygens. And you can see here, this oxygen, it has 8. It has an octet. This oxygen here now, it has an octet as well. And finally, we'll give this oxygen here an octet. Aluminum's lost all its valence electrons, but each oxygen's gained 2 to become an octet. So it's very stable this way. So because they've been transferred, they've been lost essentially to the nonmetal, we should put brackets around each oxygen just to show that. And each oxygen gained 2 electrons. Since electrons are negative, each oxygen now has a 2- charge. So we're going to put that right out here too to show that for each oxygen 2-. The aluminum atoms, they've lost 3 electrons. If you lose electrons, electrons are negative. They've lost 3 negative charges. They become 3+. And the brackets are nice because they show that these electrons aren't shared. The oxygens have taken them because it's an ionic bond. Sometimes you'll see brackets around the aluminum as well. Let's go ahead and put some in. And because we have these positively charged particles, these ions here, and these negative ions, they're going to be attracted. That's going to form the ionic bond. So this is the Lewis structure for Al2O3. Sometimes you'll see it condensed a little bit like this. We have 1, 2, so 2 of these aluminum ions, and then 1, 2, 3 of the oxygen ions. So this is another way you could write the Lewis structure for Al2O3, aluminum oxide. Do note when we're dealing with ionic compounds, it's very different than these covalent compounds. For instance, CH4 would just be 1 molecule, and they would be sharing the electrons. But here with aluminum oxide, the ionic compound, we've lost electrons to the nonmetal. So we have these charges involved. And this is what we call a formula unit. You won't find this by itself. This is part of a larger repeating pattern in a crystal. If you looked at a crystal of aluminum oxide, it would look like this, where the red, these are the oxygens, the aluminum, kind of the lighter color, and you have these repeating patterns of Al2O3, just like we drew in our Lewis structure here. This is useful, however, to really understand what's happening with the electrons in the aluminum and the oxygen. This is Dr. B with the Lewis structure for Al2O3. Thanks for watching.